Hi, I'm Craig the geologist, and today we're talking about calcite. What is calcite? Calcite is a mineral, and it's one of the more common minerals on our planet, very commonly occurring at Earth's surface, which is where you and I tend to be. So it's something you're likely to encounter a lot of when you're out rock hunting. Now, calcite is a mineral. It's a building block of rocks. It has a regular chemical composition. And it's very simple, pretty easy to remember. Is calcium carbonate, CaCO3. Carbonates are common minerals on the Earth's surface, and calcium carbonate is the most common form of it. But if you add just a little bit of magnesium in there, you end up with a different mineral altogether, then it becomes dolomite. Or if you take out all of the calcium and just leave the magnesium, then it's magnesite. If you take out the magnesium and throw in iron, it becomes siderite. There's a whole bunch of these minerals, but calcite is by far the most common of them. Calcium carbonate. The reason why the mineral is so common on Earth is that the ingredients are everywhere. Calcium dissolves from rock into water very easily. There's a lot of calcium in water. And guess what? There's also a lot of in Earth's atmosphere, and hence the water that touches it: carbon and oxygen. So you're combining three of the most common elements you find in water, other than, hydrogen, H2O, into calcite. Calcium carbonate. Carbonate, though, is a negative ion, and so it likes to bond with positively charged anions, especially ones from this side of the periodic table here, your magnesium, your calcium, and strontium is a much less common element on Earth, but you can get strontium carbonate. My table just got a little bit scrambled around here if you're paying close attention, and that's because I'm filming this segment a little bit out of order. I forgot to talk about where you find calcite usually. Calcite is a major component in the shells of marine organisms. And so when those organisms in the shallow oceans die, their shells sink to the bottom, they break down, and they leave behind calcite, tiny microcrystalline calcite that forms a rock called limestone. Limestone is a very common rock in a lot of the US. It tends to be a gray, boring looking rock. Sometimes you get great fossils in it. Sometimes it's just dull. This piece happens to have some really nice patterning in it, which is why I collected it. But that's the sedimentary rock version of calcite, basically. Limestone is made almost exclusively of microcrystalline calcite. When that undergoes metamorphism, it becomes marble. This is the only piece of marble I have. It's got a lot of fluorite running through it, which is why I collected it. The marble should be white color. This has got a lot of weathering on it, which is why it appears tan or brown. If I clean this up and gave it a good polish, it would probably be beautiful white. That's been on my to-do list since I collected it in the year 2000. So I'm sure any day now I'll get around to it. And then there is an igneous rock with a lot of calcite in it called carbonatite, named for calcium carbonate. It's a very rare volcanic rock, though. There's only one volcano in the world that erupts it right now, Old Doinyo Lengai, which, as I believe, is Tanzania or Ethiopia. I think it's Tanzania. Very bizarre. White colored lava when it hardens. It's odd stuff. But it's also super rare. You'll never encounter it. We encounter it a lot in rocks, but also in our own homes. In fact, you may encounter calcite more often in your own home than you do in the outdoors. The reason for that is calcium carbonate solubility in water leads to it leaving something behind in our kettles, in our water heaters, in our hot water pipes: limescale. Limescale is made up almost exclusively of calcite. And the reason for that is fairly simple. Calcite does something a little bit weird in water as far as its solubility goes. Most materials, when you dissolve them in water, dissolve better the hotter the water is. So for example, if you're trying to dissolve as much salt into the water as possible, you want to get that water boiling, or get it real high at least. If you want to dissolve as much sugar into water as possible and perhaps make rock candy, you get that water boiling hot, you dump in the sugar, let it all dissolve, and then you let the water cool, and the sugar precipitates out and forms crystalline sugar, forms rock candy. But calcium carbonate, calcite, does the opposite of that. It likes to be dissolved into cold water, very soluble in cold water, but as you heat that water up, it loses its solubility and tries to crystallize onto the surfaces, which is why the bottom of your kettle turns white with limescale, why your shower head turns white with limescale, especially if you live in Michigan or any other place with a lot of limestone around. Very hard water. Hard water refers to the amount of calcium carbonate dissolved in the water. And yeah, the inside of your water heater has tons of limescale. Your water pipes, your cold water pipes probably have no limescale at all. It's your hot water pipes where your cold water has come in with the probably about as much calcium carbonate as it can hold, and then it gets heated up, and now it's holding more calcium carbonate than it can hold on to, so it leaves limescale on all your pipes. Enough about limescale and how calcium carbonate ruins your home. Let's talk a little bit about calcite and how it looks when you're out in the field and collecting. Calcite is typically white to milky to colorless. It does sometimes have some faint colors, often might have a little pink or might be vaguely orange, but it doesn't tend to have very bold colors. Often you'll find it looking very crystalline, and the crystal habit and the cleavage are really some of the really defining features on it. The crystal habit, that's a reference to the shape that unbroken crystals have. Very often rhombohedral. Sometimes you do get dogtooth calcite. You get a double pyramid forming. I have a piece of limestone right here with what I thought was dogtooth calcite. And then when I started looking at it through a hand lens, I think there might be a couple of pieces of dogtooth calcite in there, but the vast majority of this looks pretty prismatic, rhombohedral. So I don't think this is a very good example. Most of the really nice examples of dogtooth calcite are in very expensive collections and museums because they're awfully sought after. But by far the more common form you get is rhombohedral. Rhombohedral, it's basically looking like tilted cubes. They're basically cubes where none of the angles are right angles. They're all tilted and shifted a bit. I think the number I hear thrown around is around 77 degrees on some of the key angles here. So if we take a look at these, you can see that there are rhombs all over. You're seeing not only crystal habit on these, but these are also fairly well broken pieces that I've got in my collection. And so you're seeing a lot of fracture as well. The fracture also tends to be rhombohedral. That means that if you break it, it will break into rhombs. It will break into smaller tilted cubes. All right, what do you say we break this guy and see how the fracture looks? Now you'll notice that this piece of calcite didn't break into rhombs quite as perfectly as I predicted. And the reason for that is that calcite can have a conchoidal fracture. That is, when it breaks under natural conditions, it usually tries to follow its cleavage planes, resulting in rhombohedrons. But when you're smashing a small piece with a rock hammer, it can break with a broken glass look, a conchoidal fracture. But you'll notice these guys do have some flat surfaces on them still where they followed their cleavage planes. That's something you wouldn't see in quartz. This is a real nice piece here. You can see all those ROMs right here on this. As you can on this one. Here's another great example here. Those tilted ROMs are a real diagnostic feature of these calcites. It makes them very easy to identify in the field. Does it guarantee what you're looking at is calcite? No, there are other tests for it as well. If you happen to have a black light with you, you can shine it on there. You can get fluorescence in some samples, and I'll show a little bit of that when it gets dark here. In fact, let's cut to that right now. And hey, here we are. Take a look at these pieces of calcite. These are the same ones that were on my desk that we've been looking at already. Most minerals will only fluoresce if there are impurities in it, and these guys are no exceptions. There are impurities that are causing this to fluoresce orange. Here is a really unique piece that I was gifted. I'm not sure where it came from, but take a look at how brightly this one glows. Another diagnostic way of identifying calcite is its hardness. Calcite has a hardness of 3. It defines the level of 3 on the Mohs hardness scale. Now, my fingernails are 2.5 on the hardness scale, and a penny is a 3.5. What does that mean? Well, it means that a piece of calcite, when rubbed against my fingernail, will lightly scratch it, but when rubbed against a penny, should not. That's a pretty narrow range of hardness. So generally speaking, if your mineral will scratch your fingernail, but not a penny, if it looks at all like calcite, then what you've got is almost certainly calcite. There are other tests also we can do, but that's usually good enough for us. Well, let's go ahead and start the scratch test. You'll see my poor beat up thumb just got a little bit more beat up. It definitely left scratch marks across my thumbnail. But if we try it on a penny, have a look at that, it left grated, powdered calcite all across my penny, but it did not actually scratch the penny itself. It's the calcite that got scratched up by it. Let's try the same thing with a piece of quartz now, though. Quartz has a hardness of 7, far harder than calcite, far harder than a penny. And here you can see it left pretty deep scratches, very unambiguous, very obvious. Let's try it with the calcite one more time. All right, I should knock that off because I'm really powdering my poor calcite there. All right, so how can we tell quartz apart from calcite? This is a major issue because calcite is one of the most common minerals on the Earth's surface. Quartz is even more common than calcite. And they tend to have, at the surface, some very similar properties. They're both often white to glassy to transparent, crystalline. They can look very, very similar to each other. However, there are some key differences. Calcite has a usually rhombohedral crystal habit, and it breaks into rhombs when you smash it. Quartz, on the other hand, while similar in color and general appearance, does not have a rhombohedral crystal habit ever, and never has a rhombohedral fracture. It has a conchoidal fracture. And so conchoidal, by the way, it means broken glass, basically. It has the look of shattered glass, which makes sense when you think about the fact that glass is made out of melted quartz sand. And so where you have these breaks here, you have this broken glass look to it, whereas if we compare it to a broken piece of calcite, we see those regular rhombs showing up, like so. The most obvious and diagnostic test for determining whether or not your mineral is calcite is the acid test. calcium carbonate dissolves readily in acid. And it doesn't need to be that strong of an acid, although the stronger the acid, the more vigorously it'll dissolve. It dissolves into even the most slightly acidic water. That's how we end up with limestone cave networks. It's the calcite being dissolved by the very slightly acidic water. But when you're testing your pieces, very often a geologist will have a little eyedropper full of dilute hydrochloric acid. Now, I've lost my eyedropper. I guess it's time to get a new one. It's about 20 years old anyways. It's really starting to fall apart. But you can also get a jar of acid. And it can be easy to find. A lot of people use vinegar. I find vinegar often isn't a strong enough acid to really show whether or not calcite is calcite. Maybe I'm just impatient. Maybe I need to let it sit for a half hour or so. But when I'm looking for a result, I'm looking for a result in seconds. And so I use hydrochloric acid. And you can get hydrochloric acid also very easily. This stuff is sold in Home Depot, pretty much every hardware store. It's muriatic acid. Muriatic acid is another name for hydrochloric acid. This is... What's the strength on this? 31% hydrochloric acid. You do not need it to be that strong and should not have it that strong. So what I've got here is a jar of water. I'm just going to pour a tiny bit into the water here. Probably enough to dilute this to around 10% or so. And freeze. Years of working in a chemistry lab have, rather than made me pedantic and very cautious, have made me very cavalier about the use of hydrochloric acid. And so there are a number of safety precautions I'm skipping that would make any OSHA person or any lab manager weep and then kick me out of their lab permanently. When you do this yourself, there are a few things you should be doing that I'm not demonstrating properly. Using hand protection, perhaps a long sleeve shirt, certainly not doing it in flip-flops. You will notice when I pour this, a little bit of it splashes, and I don't have paper towels to clean it up, and I don't have baking soda to neutralize it. You'll also notice that when it does splash, it's not the end of the world. This acid is not strong enough to melt the flesh from your bones. It'll give a very, very light burn if you leave it on for a little bit. But when you do this yourself, be safer than me. In fact, when I tell people how to do these things, I usually give them the instructions: be cautious, be prepared, be better than me. All right, and I've spilled it. It's splashed out, which is why you need to be very careful. I am immediately going to get a paper towel and clean that up. Now, hopefully those splashes demonstrated to you why it's better to do these kind of tests outside, because you don't want hydrochloric acid splashing around your house, even dilute. It's not good for anything. But it also can produce some fumes. And so it's good to do it in a well-ventilated space. This is a very large room, not well ventilated, but it's large at least. So after I'm done with this, I will move it somewhere else and put a fan in here and blow it out so I'm not huffing hydrochloric acid. But without further ado, let's have a look at what this does in here. By the way, just for comparison, let's drop a piece of quartz in here. The quartz is entirely unreactive. Now let's go ahead and drop in a piece of calcite. Well, that's a very vigorous reaction. You can see that bubbling away. In fact, you do this experiment all the time, especially if you have indigestion. Stomach acid has a heavy component of hydrochloric acid in it. And when you take a Tums antacid, Tums is calcium carbonate. And this is what happens and why you end up burping a little bit and your stomach feels less acidic. While calcite does dissolve and fizz vigorously in acid, most materials will be unreactive. And so if there is vigorous fizzing, that could be an indication that you've got calcite. While we're at it, let's talk about limescale a little bit. This is a limescale in the bottom of my kettle. It's white. You should probably recognize it from your own home. I bet you've got some in some places where you have hot water flowing, either in a kettle or on a shower head. This is pretty much pure calcite. Now, we could clean this up with hydrochloric acid, but that's not safe for cooking with. You don't want it on cooking surfaces, so we're using vinegar. We pour it in. Vinegar is acidic. It will do the same thing as the hydrochloric acid, just in a slower way. and in a way that won't be dangerous for you to use that for cooking later. You will see it slowly dissolves the limescale, the calcite, same way hydrochloric acid will. And after a couple of minutes, you'll have a clean surface. This is a great way to clean shower surfaces, shower walls, shower heads, kettles. Anything that advertises limescale removal is basically an acid that eats it away, just like this. Hardness is another tell. We can use a piece of scrap glass, and I'm going to use this emptied out container that I used for our acid test earlier. And glass has a hardness of around 7, I think, as I recall. And quartz has a hardness just above 7. And so quartz will scratch glass. Calcite with a hardness of 3 will not scratch glass. So let's go ahead and give that a test right here. Starting with the calcite. Here we go, our second scratch test of the video, this time using glass. Really focusing on the scratch test because hardness is such a great way to tell the difference between minerals. You'll see here, it looked like it scratched it, but then you wipe it away and nope, that's just powdered calcite that was left behind. How about the quartz though? Now there's less of a difference between the hardness of glass and quartz than there is between the hardness of a penny and quartz. So you do have to press a little bit harder and look a little bit closer. But when you do have a close look at this video, you will see that there were scratches definitely left behind in the glass. Let's press a little bit harder. All right, well that's not ambiguous at all anymore. You can see those scratches that were left behind. And just in case you thought I wasn't pressing hard enough on the calcite, let's grab that piece of calcite and try it one more time. Really grind it in there. And yeah, it just powdered my calcite. Didn't leave any mark at all on the glass. All right, so as you can see, it did scratch the glass, the quartz. Calcite did not. Make sure if you're doing the scratch test on some glass, you pick a piece of glass that your partner or spouse is not going to be mad about you scratching up. Geology kits for students often have a little square of scrap glass, a little glass plate that they can scratch up. I don't have anything like that handy at the moment, so I just use the bottom of some ball jars and figure the wife won't notice the scratches on them. I hope you learned a little bit about calcite and how to differentiate it from quartz and some other minerals. Get out there, have some fun, and I'll see you next time.